In this lecture, we will study the last topic of the first module, that is Verilog hardware description, which you also say like VHD Verilog HDL program. Okay, so Verilog HDL program, which is usually known as like that. So Verilog hardware description language. In short form, we call it as Verilog HDL. So basically, we have three models in this to study. So one is gate level and data flow. Gate level also known as structural. Okay, gate level or structural modeling, data flow, and the third one is behavioral. Compared to all three, we say the third one is the easiest one, because for the behavioral model, we don't have to draw the diagram. Okay, diagram in the sense logic diagram. So basically, they provide us with a diagram. According to that diagram, we have to write a program code for all the three, for that particular logic diagram. So most of the people will think how to program itself means they will think it's difficult, but there is nothing like that. It is the easiest topic of this model, because just small thing. In this two, there is everything is completely same to same program. Just one line will change, and here if you understand this, it will be easy for you to write this, and automatically it will be easy for you to write this. And before I start, let me just tell you the symbols for the expression. You know, this symbol is for AND gate. It's usually there in C language also, and only this one straight line is for your OR gate. And for NOT gate, before any letter we give this symbol to say it's NOT gate. Okay, and we also have for XOR, like exclusive symbol, we have this. So let me write the symbols down, and this is for this AND or NOT XOR. Okay, so just see these ones and note it down somewhere if you want. So now let us take one example and then write the code all three data flow models for this diagram. So here I am taking one diagram A, B, and make sure you don't use capital letters inside the diagrams, because we will be using small itself, small letters. Okay, so here like this, and here. So our output is y, this is our y1, this is our y2. What is this y1 and y2? This is yr y1 and yr y2. So for you to understand why we have written yr, let me just write here and explain you. So suppose this is that dabba means what? Your experiment box which you perform experiments. So here we will be having some circles for your output lines, and here we will be having your circles for your input lines. And here you will be having 4 boxes in which you can put the IC chip, and then you will have particular holes in this also, like this, with particular numbers. Okay, and here you will be having your switch for each thing. So suppose this is our AND gate. Okay, AND gate, and this is our NOR gate. Because why anything can be any gate, because it depends on the IC chip which you put in the middle of this. Here middle you will put one IC chips. So suppose here AND, this is NOR, we put the IC not NOR OR. Okay, so suppose this was A, I will put here, this was B, I will put here, this C I will put in the output side. And now here, now you can see, no, I won't put this in the output, this I will take here, and again one more I will add like this, 3 more. So this A, B, and this C, D, E. Again one I will connect here. So one went here, one went here. So from this two, again one will go like this, something like that will be there. So now you can see here, from this gate to this gate, 2 wires were connected. For A, B, one was going here, and for C, D, E, for the 3 inputs, one wire went for OR gate. From here one went here. So the 2 wires which went from this gate to this gate, that is our wire we are using here as a y1, y2 and all. So that was it. So let us continue here. So for this, now one by one we will write the code. So, as you can see, for data flow, first for everything you have to write module, and then followed by you can give any name for you. So, I will give GL, gate level, in the bracket all the things you have to write, your input and your output, A, B, C, D, E and Y. Here we will not be writing what to say Y1 and Y2. Why? Because it is not our input neither output, it is just a wire which is being provided in between the circuits. Okay. So, then now here won't bracket and all won't come like your computer, just you have to write input A comma B comma C comma D comma E. In exam what you do, write input A, input B, input C, input like that till the end, then output Y, then wire we have to write like this Y1 comma Y2. Now, first what you have to do, you have to write the name of the gate, first gate, and that will be your G1, obviously G1. So, see here, this is your G1, this is your G2 and this is your G3. Okay. For G1, first you have to write what is the output line going and then followed with the input. So, what is the first thing here, output there. So, Y2 comma A comma B. Understood? Again I will write AND gate here, G2 is the AND gate, right. So, what is the output going from this gate, that is Y1, then Y1 comma C comma D comma E. Just write, no need to write in any order like that, I have to write in order itself, but just write like this. You can put comma aram se. Then OR gate, for OR you just write OR like this, and that will be your G3. What is the output? Y. Now, do not write A, B, C, D, E, F, G, okay. Just write Y2 comma Y1. Now, if I had written Y1 here and Y2 here, the respective place it will change, and here Y1 comma Y2 will come. Since I took Y2 here and Y1 here, so Y2 comma Y1 is coming here. Okay. Then simply I will write end module. Over. This is my gate level program for the following this what to say. So, what here, nothing you have to like learn here, everything module, this line will be same in everything, this also will be same in everything, this also will be same in everything. Just your wire it will be there for first two, but wire won't be there here. Why there won't be a wire line in behavior model? As I said, there is no logic diagram itself for this. Directly from the expression you can write the code. So, let us write data flow here. So, what we will do again, module, I will write df for data flow. You can write anything over there, same again you have to write A comma B comma C comma D comma E comma Y. Again input A comma B comma C comma D comma E, close it, output Y, close it, wire Y1 comma Y2, that is it, close it. Now, see here, this thing was same. Now, here what we will do, instead of writing this gate name and or and giving this, simply we will write the function as assign, SSIGN, assign. Now, what is this first output here, Y2 is equals to A and B, okay. Then assign Y1 is equals to C, D, E, and its right. Then again we will write assign Y is equals to Y1 plus Y2. Then that is it. Then what we will write? End module. Let us cross verify. Okay. So, what we wrote is same itself. So, now you can see, compare here, I will write in the pencil, only this part is being replaced or changed, yeah, as you can see, and the remaining everything is same. So, the last is your behavioral model. So, this again the starting these lines are same till here. What changes is from here, you won't write wire, you will let us still write module. I will write behavioral model, I will write down the bracket A comma B comma C comma D comma E comma Y. Now, what will write input and here output A, B, C, D, E, and here output Y. Now, what I will write? I will write begin here, okay. Sorry, here you have to write first thing, always at, and in this you will be having your input. A comma B comma C comma D comma E. So this one line is extra here, always at, then begin and end will come, begin and it will end somewhere, and then end module, and between this we will be having a y function. Y is equal to, now see here, this is the easiest thing, y equals to directly whole thing you can write A and B in the bracket plus C, D and E. So that's it. This is how you write your all the three modules, all the three data flow models 1, 2 and 3 for this diagram. So you can change the diagram and also write another like code. So if you want, take a screenshot of this, and or else better you write and practice it. So I will take another example because one example is not enough. So just let me copy down the diagram. So we have here like this, and then for C we have one NOT gate like this. So these both are connected with OR gate. So here we have 3 gates. So let us see how we can do this. So let us put A, B and C. Here C bar will come. So finally our output. So this let me keep as y1, this is y2. Y is equals to A into B plus C bar. Okay. So now let me start with data flow gate level model. So I will write module gate level. What I will write, all the inputs A, B, C and then output. So input same thing, A comma B comma C, like computer C language will close with that. Here also I think it will be there, just I will later check and tell you if it is there or not. Then output you have only Y, then again wire Y1 comma Y2. Sometimes Y1 you will think this one as comma and leave it, don't do that mistake. Now then what we will do, start AND gate. First you have AND gate, now we have to name it as G1 and these are G2 and these are G3. G1, what is the output going first is Y1 comma A comma B. Now this is your NOT gate, what is that, G2, what is the output going, Y2 comma only C. Now you have your OR gate G3, what is the output, Y. Now what you have as input, Y1 comma Y2. Okay, like this and end module. Over we will do for data flow, module data flow. I won't write anything, this all part are same, this is also same, only this part I will write here. So assign here Y1 is equals to A and B, then again assign Y2 is equals to not of C. Now how you will write not of C, just put this tilde symbol C over, then again assign Y is equals to Y1 plus Y2 over. The same thing which I put here, this bracket same thing, this 3 lines same thing here. Now in data, like last is behavioral model. So again module behavioral model A comma B comma C comma Y. Now input here, output what will have, A comma B comma C, here only Y. Now always at A comma B comma C, inputs itself will give, then begin and one place it will end, right, then end module. Now here what we will have, the expression Y is equals to A and B or in the bracket C, that is it. So see here we will have in this data flow, oh sorry, one thing I forgot here, we have to register the output first, register Y, then we can go for output. So let me correct it here also. Before always at this was input, right, so then you have to write register Y, same thing, output Y, register Y. Okay, why you have to register the Y, because whatever the value we are sending in this always at, right, suppose it is a register, this value will be sent to this register and then at the end of the module the Y will be written as the result. So see here register Y, you could have studied this topic, you can understand more easily in the third module, where you have to pass, you will be knowing about studying about registers and other things, where how you like send the things values, pass the values to register. Even there you will be having some code to write there, like load A comma R1. So the A value of A will be loaded to R1 and location of A will be sent somewhere, add a comma r2, so a value of a will be added to r1 like that. So this is how you write your data flow, gate level, data flow and behavioral. For this too you have to draw this diagram mandatory, and for this you should write the expression y is equals to ab plus c bar. Only with the expression you can write this. If they have given the data flow, write this. Sometimes they will give only the expression, and with any one module data flow model to draw, like write the code, you can just directly go for behavioral model because you don't have to draw the diagram. But if they are specific like data flow or gate level, then you have from the equation you have to draw this and then write like this. They can also ask this for XOR gate. It's small one, but how will they ask? Just they will give XOR gate, no equation, nothing. So you should know that XOR gate means A exclusive B, which is nothing but A B bar plus A bar B. So how you will write for that? Directly you can write from this. Suppose y is equal, like for behavioral you can write what you will write, y is equals to A m and like B will come like this, then A B. So you have to just replace this in this place. Okay. Now what you will be having, only AB will be there, so C won't be there here, just AB. In place of this line you have to write this. Similarly how you will change here, you have to draw the diagram. According to this, how will be the diagram? This is for your AB bar. So this is your A bar B, and just add it. So AB bar plus A bar B, y is equals to AB. So I took a capital, don't take capital, write small letters. From this diagram you can write. So see here, you have here many gates here. So this will be your G1, this will be your G2. In G2 what you will do is simply you have to write what is that? What is the output? You have to write here. This is y1, first wire is here. Okay. Then you can say this as y2, second wire. Then this as y3, and here y4. Then you can write y1 comma b. So you have to do that. So let me write because it's a bit confusing and different one. So module a comma b, that's it. Then you have by input output. So you have only a comma b, here only by wire you have 4 wires, y1, y2, y3, y4. Now how you will write? So first AND gate. In AND gate what you have, so we have made that as G1, right? So what we will put in AND gate, first what is going out is y2 is going out, comma a comma b. Here then we will put not, we have that is G2 we have given, so that is y1 comma b. So first it's better to write this here and this here because here y1, so anything is fine. So better you replace it and change this as G1 and this as G2, and this as G3 and this as G4. So this is G2 G1, just replace it. Then I will write for not again G3, so that is y3 comma again a is going here. Then again I will write and here, that is G4, in which I will write y4 is going as output a comma b itself. Then what is that last, or that is G5, what is the output going y comma here, what is the 2 wires, y2 comma y4, everywhere colon. Okay. So end module. This is your behavioral. For data flow, how we will write?